All right, let's take a look at topic 3. We're going to look at volume of prisms and cylinders. And if we were to look at the first two words down below, perimeter and area, we could say that the perimeter is going to be the distance around the outside edge of an object. So the distance around the outside edge of an object. Now, area is something we've been working with for about a week. Now, area is going to be the space covering the inside of a 2D shape. The inside of a two-dimensional shape. Okay, volume or capacity, sometimes we interchange those words, and it's going to be the amount of space inside a three-dimensional object. So when we talk about capacity, most often in everyday life we talk about some common examples such as water bottles. How much liquid can they hold? The water in a pool. Cereal in a box. Or you might talk about the air inside of a balloon. Okay, just some common examples we use all the time. Okay, so if I were to look at this using those linked cubes, which are 1 centimeter by 1 centimeter by 1 centimeter, we could build the following prisms. So one has a length of 6, a width of 4, and a height of 2. And we can look at the area of the bottom. And what we are going to notice is we can count 3, 4, 5, 6. We can count the dimensions of the rectangle on the bottom. So we're going to be a 6 by 4 rectangle. And we're going to have our formula, which is length times width. It's the area of a rectangle. And we could say that it's 6 multiplied by 4. And if these cubes are 1 centimeter in length, that means our area has to be centimeters squared. So the area of the bottom is 24 centimeters squared. Now we have to figure out how many cubes are needed to build the prism, keeping in mind that the height is 2 centimeters. So if one cube has a height of 1 centimeter, in order for the prism to have a height of 2, I have to add another layer to the top of this. So since the bottom layer is 24 cubes, we're going to have to double that for the second layer, and we're going to need 48 cubes to build the prism. Okay, part B, our dimensions are listed there, so a length of 3, a width of 2, and a height of 8. And we could look at the area of the bottom of this prism. So again, area is going to be length times width, and we have dimensions of 3 cubes by 2 cubes. That makes up the base. And again, they are centimeters, so I have to have an area of 6 centimeters squared. Okay, this time our height is changed, and our height is 8. Okay, so if the bottom layer of this prism takes up 6 cubes, I have to figure out how many cubes I need to raise the height of this prism to 8. So what we're going to do is take the 6 cubes for the base and multiply it by the 8 layers in total, so 8 layers, to get the total number of cubes. And again, we're going to have 48 cubes, the exact same number as above. Okay, so what you can see is even though the area might change, the volume stays constant. The area might change, but the volume stays the same. Okay, so using those cubes again, what formula expresses the volume of our rectangular prism? So the quick way to deal with volume is to take the area of the base and multiply it by the height. Okay, so we can take the area of the base. So since the base in this case is going to be a rectangle, shaded in down below, we're going to take the length, multiply it with the width, and then we're going to multiply it by the height. So the volume of a rectangular prism is going to be length multiplied by width multiplied by height. Now we're going to have to figure out what our units for volume are. And our units are going to be cubed. So these are the case like centimeter cubed, feet cubed, inches cubed, and so on and so on. So I look at that first example. Luis sells different sizes of fish tanks in that pet store, and the dimensions are given along with the pictures. How much water will be needed to completely fill each tank? And if we're talking about an amount of water to fill something, we need to figure out the volume. We need to find the volume. Now we're going to find the volume of all 3 tanks. So maybe tank 1 we'll do in blue. So the volume is going to be length times width times height. And here are my dimensions, 20, 60, and 20. So what we're going to do is multiply all of those together, and we're going to get 24,000 cubic centimeters. Okay. In red for tank 2, length times width times height, 20 multiplied by 20 multiplied by 40, and we get 16,000 centimeters cubed. So even though they are the same shape, they're both rectangular prisms, you can see that the volume varies quite drastically. One tank is larger than the other. Length, width, height. And if I look at this last third one, all dimensions are 20, so this is now a cube. And I get 8,000 centimeters cubed. Okay, so now we have how much water is needed to fill every single tank. And if we look at part B, we are asked to look at tanks 2 and 3. How many dimensions have changed? By how much? And how does the volume of tank 2 compare with that of tank 3? So we're going to compare the dimensions of the second and third tank. So I'm just going to zoom in a bit. Now we can see that the only dimension that's different is the length. And for tank 3, that length has been cut in half. So the length of tank 3 has been cut in half. Okay, how does the volume of that tank compare with that of tank 3? Now we're going to compare the volumes that we looked at. So in tank 2, it was a volume of 16,000, and tank 3 had a volume of 8,000. Now what you're going to notice is the volume of tank 3 is half that of tank 2. So the volume of tank 3 is half the volume of tank 2. Now that's no coincidence. Since we changed the dimensions of the shape, and we've changed the dimensions, and we've reduced it by half, our volume is going to be reduced by half as well if we make the dimensions smaller. All right, part C, 1 liter of water equals 1,000 centimeters cubed, and we're going to convert the volumes of the fish tanks into liters. So this is where we talk about our proportions, like we talked about a couple weeks ago. Okay, so I know that 1 liter is equal to 1,000 centimeters cubed. Now we'll grab our blue pen because that's what we said tank 1 was. And we're going to match up our units. So if on the right I have centimeters cubed, on the right I should have my value for centimeters cubed. And we're going to figure out how many liters that amount turns into. And if we were to do our cross multiplication and then divide by the number that's left over, we get right to our answer. And we end up with x being equal to 24 liters. Okay, we can continue this process. So 1 liter is 1,000 centimeters cubed. We're going to use red this time. Again, match up your units to units. So 16,000 centimeters cubed, x liters. And if you followed the same process, we should get 16 liters. And for green, our tank 3, 1 liter is equal to 1,000 centimeters cubed. Let's grab our green marker, 8,000 centimeters cubed. My unknown goes in the other spot, and we end up with 8 liters. Okay. So we can compare the dimensions and have an idea of what the volume is going to be. Okay, so that would be a rectangular prism. We'll end the video here, and I'll post another one talking about cylinders.